Okay, so let's start our today's lecture. And good evening, everyone. It's pleasure to see you here today. And welcome to our ninth lecture in the course on legislation aspect of fire safety management. And today we will move on the fascinating and some complex real world of fire safety management for some special buildings. So those special buildings are not your typical structures, and they include some historic treasures, high-rise buildings, and some assembly spaces and unique entertainment like karaoke bars. So each of these buildings present its own challenges, requiring some tailored regulatory approach and also the thoughtful management strategies. So over the next 3 hours, we will explore how fire safety principles can be adapted to preserve life, property, and heritage in this kind of specialized context. Okay, so let's begin our today's lecture. So our today's lecture is structured around the four main categories of the special buildings. So the first is the historic buildings, and then high-rise structures, and the assembly occupancy, and also the karaoke establishment. So each of these categories brings distinct fire safety concern, and we will examine how legislation, fire safety, and management practice are specifically designed to address those concerns. So our aim is not only to understand the regulatory framework, but also to know the reason behind these rules. So, for instance, why do we treat a century-old temple differently from a modern shopping mall? And how do we ensure safety in a 100-story tower or a packed concert hall? So, by the end of this session, you will have a comprehensive understanding of those approaches needed for the diverse environment. So let's begin with the historic buildings, which are invaluable cultural assets, but also present significant fire safety challenges. So in many regions, including Hong Kong, there is surprisingly limited formal guidance on how to maintain and refurbish those structures while ensuring fire safety. So the primary legislation tool we have here is the Antiquity and the Monument Ordinance, Cap 53. So this ordinance provide a foundation for protection, but it is not offer detailed fire safety specification. So this gap means that the fire safety professionals must often rely on some international best practice and a deep understanding of both engineering and heritage conservation. So, for example, when dealing with a clarid monument, we cannot simply install standard fire doors or alarms without considering their impact on the building's historic integrity. So, when we talk about protecting historic buildings, one of the core principles is to minimize the intervention. So that means we aim to preserve as much the origin fabric as possible, while we still ensuring the safety of our occupants and the building itself. So to achieve this, we focus on several key elements, such as the building use, the means of escape, the signage, and also the firefightings. So, for instance, if a historic building is repurposed as a museum, we must control the fire load, which is introduced by exhibits, while ensuring that escape routes are adequate for the number of the visitors. Similarly, firefighting measures must be effectively without causing correlated damage to those irreplaceable materials. Clearly definition and controlling the use of a historic building is the critical first step in the fire safety management. So different area within the building may serve different functions, and each functions carry its own fire risk. So for example, a historic mansion might have a ground floor open to the public for tours, while the upper floor are used for some administrative office. So the fire load, that is the amount of combustible material, must be carefully managed in each zone. So in the public area, displays should use non-combustible material ever impossible. Meanwhile, some office area must adhere to strict guidance regarding the electrical appliance and the storage. So for the means of escape in the historic building often fail to meet modern standard. Many of these structures were designed long time before those current codes were established, featuring the narrow staircases, limited access, and inadequate protection against the smoke and the fire. So, as a result, we cannot solely rely on some physical infrastructure for safety egress. Instead, we must implement robust management strategies such as controlling the number of occupants and training staff in some crowd management. So imagine we have a historic theater with a single staircase. So in an emergency, staff must be prepared to guide visitors calmly and efficiently to safe, perhaps using some predetermined and assemble point outside of the building. So those kind of human element is just as important as the physical design itself. So also some effective signage is very important for guiding people to safety, especially in the complex and unfamiliar environment like historic building. However, we must install signs in a way that does not remove the building's aesthetic or historic value. For example, in some preserved colonial era building, placing a large bright exit sign on a hand-carved wooden panel would be inappropriate. Instead, we might use some smaller sign that blend with the decor or use some indirect lighting to indicate escape routes. So another innovative approach is to incorporate some directional cues into the building's existing features, such as we can use floor lighting along the edge of the corridors. So understand the fire resistance of the historic building material is a complex but very essential task. So many older buildings were constructed using materials like timber or some traditional plaster, whose fire performance may not be well documented. For instance, some heavy timber beams can sometimes offer inherent fire resistance due to their masses, but this is not always predictable. So when introducing new elements such as electrical wiring or some partition walls, we must carefully assess how they will behave in this fire. So will they compromise existing structure, or could they create new pathway for fire spread? Those questions must be answered through some thorough risk assessment and testing or modeling. Also, in the historic buildings, often contain some hidden voids. That is, the spaces within the walls or floors or roofs that are not immediately visible. But those voids can be created over time through modifications and some additions or repairs. So while they may be harmless, under some normal conditions, in a fire, they can act as channels for the smoke and the flames to spread rapidly and undetectedly. So, for example, in an old school building converted into apartments, false ceiling might contain some voids that connect multiple rooms. So to address this, fire detection system should be designed to monitor this hidden area and perhaps using some smoke detector that can sample air from voids. So early detection in this space can prevent a small fire from becoming a major incident. Okay, so this slide shows an image for a traditional pottery workshop, which serves as an excellent example of the historic building with a complex layout. The presence of the kilns, the storage area, and the workshop within one structure creates multiple fire hazards. Additionally, the building's age and the construction's material means that the fire could spread quickly through hidden voids or combustible structure element. So when dealing with such sites, a thorough understanding of the building's history and the usage is essential for developing an effective fire safety strategy. Okay, so for in the historic building, the installation of the fire detection system must be both effective and unobtrusive. The traditional smoke detector can be visible intrusive, and there are some alternatives. For example, some gas sampling detection system can draw air from multiple points through the small hidden pipes to the central detector. So this allowed for early warning without the need of the visible device in every zone. Another option is to use some miniature detector that can be discreetly mounted within the existing fixtures. It is also important to address the issue of the false alarm, which can cause unnecessary damage during the evacuation or fire survey response. So an analog detection system can provide early pre-alert signals to the management, allowing for some investigation before full evacuation is triggered. So this slide shows a common mistake, placing a smoke detector directly on the painted ceiling. So not only does this detract from the artwork, it may also be ineffective if the detector's airflow is blocked by decorative element. So in historic setting, every installation must be planned with with some sensitivities. So for instance, in a room with a decorated ceiling, the detectors should be mounted on adjacent walls or within some ventilation ducts. The key is to collaborate with heritage conservation to find the solutions that meet both safety and the preservation goals. So this collaborative approach ensures that we do not solve one problem while creating another problem. Okay, so when it comes to fire suppression in historic building, the choice of the system is very critical. So some water-based sprinklers are effective, but can cause significant damage to irreplaceable items like some documents or textile or some wooden artifacts. For example, in a historic library, water damage from a sprinkler activation could destroy rare manuscripts. Therefore, we must consider alternative agents such as inert gases or fine water mist, which are less damaging for our historic building. So if a sprinkler are unavoidable, the design must account for some issues like the condensation from pipes, which could promote the mold growth. Also, each decision should be based on a careful assessment of the risk versus the potential damage. So this image shows the water damage in a historic interior. Where the fire itself may have been controlled, the water used for suppression has caused some warping, staining, or loss of the original material. So this is a reminder that the method of extinguishment must be chosen with some care. So in some cases, localized suppression, such as using the pre-plumbed hose reel or some portable extinguisher with the appropriate medium, may be preferable to the area-wide sprinklers. Some new technologies are providing effective fire suppression with minimal impact. So one promising approach is hypoxic air system, which reduce the oxygen level in the protected space so that the combustion cannot occur. This is achieved by introduce filtered air. For example, in an historic archive, such a system could protect the entire collection without any risk of water or chemical damage. And this system require careful design and monitoring. They represent a significant advance in the protection of the cultural heritage. As fire safety professionals, we must stay informed about such innovations and assess their visibility to specific projects. So here we can see an excellent example of how fire safety system can be integrated sensitively into a historic setting. At a historic church in Vietnam, a service pillar combines both electrical outlets and a sprinkler head in one unit. So this design minimizes visual impact while providing essential protection for the church. And such solution require close collaboration between architects, engineers, and also the heritage specialties. They demonstrate that with creativity and careful planning, we can meet fire safety requirement without compromising, uh, without promising any aesthetic or historic value. So this is a model we should aspire to in all heritage projects. Also, when we come to the emergency lighting, it is a critical requirement for safe evacuation. But in historic building, its installation must be handled carefully. So wiring should be routed discreetly, perhaps within the existing conduits or along the structural element. For example, in a historic church, some emergency lights could be incorporated into the existing walls or mounted on columns in a way that respect the architectures. So the system should be independent of the main power supply and can be automatically activated during a failure. So proper planning ensure that occupants can evacuate can evacuate safely while preserving the building's characteristic. Also, now we come to the staff aspect. Some comprehensive training is essential for everyone involved in the operation of a historic building, from the management and the staff to some contractors and the security personnel. So, for instance, in a historic hotel, staff should be trained not only in evacuation procedures, but also in daily fire prevention measures, such as the safe storage of proper use of the electrical equipment. And also, the contractors performing hot work like welding must obtain permits and follow strict safety protocols. And also for the security staff, they should be familiar with the operation of the fire detection system and also the emergency communication procedures. And the regular drills and the refresher courses can help ensure everyone is prepared to act quickly and effectively in an emergency. So that's why we need some regular drills and some courses. And many historic buildings were constructed at the time when modern firefighting vehicles and equipment did not exist. So as a result, access for emergency vehicle might be limited. In such cases, we must develop alternative strategy such as identifying nearby water sources or installing dry riser within the building. For example, for a historic manor located in a rural area might rely on a nearby pond or a streams as a water supply. Also, some regular site visits and the joint exercise with the fire service are very crucial for the firefighters to understanding the building's layout and the specific hazard. So the good communication between the building management and the fire department can significantly improve the emergency outcomes. Okay, so now we come to some organization for the historic buildings. The organization like Historic Scotland have developed some detailed guidance for the fire safety in the historic building. Their technical advice notes, such as TAN11 on fire protection measures, and also the TAN25 on the fire risk management, provide some practical evidence-based recommendations. So these documents emphasize a risk-based approach, recognizing that full complying with the modern codes may not always be feasible or desirable. Instead, they encourage some alternative solution that can achieve the equivalent level of the fire safety. For example, the TAN14 offers the guidance on the sprinkler installation that can minimize the visual and the physical impact. So such results are invaluable for the professionals working in such field. So, as we mentioned in our last class, NFPA is a kind of organization that in the USA, right? So the NFPA 914 is the code for the fire protection of the historic structure. And this code highlights the specific features that can pose the fire risk, such as the open styles. While these styles are often architecturally significant, they can act as some channel, allowing the smoke and the fire flames to spread vertically. So, for instance, in a historic courthouse, an open staircase might connect multiple floors, compromising the integrity of the escape routines. So the NFPA 914 suggests measures like installation of fire-rated enclosures or using some automatic closing doors to protect these stairs. However, any intervention must be carefully designed to preserve the style's historical and the intrinsic values. So this slide shows an innovative solution, an accordion-style door used to protect a stairway during a fire. So when it closed, the door prevents smoke and the flames from entering the stair enclosure, thus can maintaining it as a safe escape route. So this door is designed to be decreed when open and only deployed when needed. So this approach demonstrates how modern technologies can be applied to meet the heritage conservation goals. And in the building with large historic windows, some sprinklers can be used to cool the glasses during the fire and can reduce the risk of the breakage and prevent the fire spread to some adjacent areas. So, for example, in a historic gallery with the stained glass window, targeted sprinkler head can protect these irreplaceable features while also enhance the overall safety. So this application shows how fire protection systems can serve multiple functions when properly designed. So it also highlights that the need for the specialized knowledge when working with the unique architectural element. Also, we can see this picture. Here we see how sprinkler pipes can be concealed within the historic structure to minimize the visual impact. So in this vaulted ceiling, the piping is run along the corner at the base of the vaults, so it is less noticeably. And similarly, pipes serving sprinkler heads can be hidden behind the bins. So this approach required careful coordination during the installation, but results in a system that is both effectively and unobtrusive. So this image also shows a sprinkler head, but it is installed at the center of the decorative ceiling rooster. So by integrating the sprinkler into an existing decorative feature, the visual impact is minimized. So this solution preserves the room's aesthetics while providing the essential protection. Such details may seem very small, but they can make a significant difference in maintaining the historic integrity of the space. So they also demonstrate the value of custom design components in some heritage fire safety. Okay, so in this slide, we see some smoke detectors. Those smoke detectors have been color matched to the ceiling. So this is very simple, right? But it is an also very effective techniques can help the device blend into the background and reducing their visual intrusion. And similarly, linear beam smoke detector can be used in a large open space where the point detector would be much obvious. So here is the project beam smoke detectors. Those projective beam smoke detectors are ideal for protecting the large wooden space in some historic building, such as the halls or worship area. So this system consists of transmitters and receivers that project a beam of the light across the space. So if the smoke interrupts the beam, an alarm is triggered. For example, in an historic railway station with a high decorated ceiling, the beam directors can provide coverage without the need of the multiple visible devices. So this technique offers some reliable detections while respecting the architecture. So those is our Hong Kong 2021 guidebook. This guidebook is for the heritage buildings. And this guidebook provides a practical framework for adaptive reuse and alternate works. It emphasizes some balanced approach, recognize the restrict compliance with standard may not always be possible. Instead, it encourages alternative solutions that can achieve the equivalent fire safety. For example, if a historic staircase cannot be widened, some additional measures like enhanced detection or staff training might be accepted. So this guidebook also includes some case reference and sample managed plans, making it a valuable tool for our firefighters. Okay, now let's turn from the historic building to some high-rise building. Okay, so those high-rise buildings define the skyline of the modern cities, but it also presents unique fire safety challenge. Structures like the Khalifa Tower in Dubai, which stand at 828 meters, requires some sophisticated safety system to protect the occupants and also the property. So these sheer heights introduce the issue such as the prolonged evacuation time and the stack effect on the smoke movement, and also some access for the firefighters. So in this session, we will explore how regulations and the technologies can adapt it to address those challenges. So here in Hong Kong, the International Commerce Center, or ICC, stands as our tallest building at 484 meters. So its design incorporates multiple fire safety features, including the pressurized stairwells, advanced smoke control systems, and some dedicated firefighter lifts. So those elements work together to facilitate the safety evacuation and the effective emergency response. The ICC serves as a living laboratory for high-rise fire safety, demonstrating how engineering innovation and the regulatory framework can combine together to protect the life in ultra-tall structures. And in our Hong Kong skyline also includes the other high-rise buildings, like those two international financial center, Central Plaza, and the Bank of China Tower. So each of those buildings have contributed to the evolution of local fire safety. For example, the distinctive geometry of the BOC tower influence how wind and the smoke movement are modeled in some tall structures. Studying those buildings help us to understanding the dynamic interplay between the architects, engineering, and regulation in achieving fire safety. So several key factors must be considered in our high-rise fire safety. These include the accessibility of the firefighters, egress and people movement systems, occupant and material load, and also some internal utilities of the service. So the impact of the natural force on the smoke movement is also very important for some key factor. For instance, a mixed-use tower might contain some office, hotels, and retail spaces. Each of them has its own fire risk and evacuations. So the internal utilized service, such as the electrical rooms and the HVAC systems, must also be designed to prevent the fire spread. So a holistic approach is essential for manage this complex environment together, and we can consider those key factors in an integrated way. Okay, so now let's get into our assembly occupancy. The assembly occupancy are spaces where a large group of the people gather for activities like some workshop, entertainments, or some deliberation. So this can range from the theaters to some terminals and also some special amusement buildings. So the primary concern in this setting is the fire safety, so as the density of the occupancy can lead to a rapid crowded dynamics during an emergency. So in this section, we will examine the unique characteristic of the assembly spaces and the regulatory measures designed to keep them safe. So assembly occupancy are defined by the presence of 50 or more people as is stipulated in the code like NFPA 101. So the number of the occupants creates some unique hazard, such as the potential of the panic and the difficulties of the managing crowd flow. For example, in a sport stadium with thousands of spectators, some evacuation must be orderly and efficient to prevent our crowd and our crashes. So those human behavior in these kind of settings is as important as the physical design of this space. So the building code and the NFPA 101 set that the minimum number of the occupants and also the structure with the group of people gathering for the purpose. So we need to understand their numbers, their purpose, and we can propose some other kind of specific fire safety management to keep them safe. So, people in assembly occupancy are also unfamiliar with the building layout and may be disoriented, especially in some condition of the low lightings. So, for instance, in a cinema during a film, the lights are dimmed and the audience are focused on the screen rather than their surroundings, right? So, in an emergency, clear announcement and the well exit passes and also the trained staff are very essential for guiding people to safety. Additionally, the density of occupancy, sometimes as high as one person per 0.46 square meters, requires careful planning to avoid congestion at the exits. So we need to consider of the different types of assembly. Different type of the assembly space present specific challenges for our firefighter. For our restaurants and some nightclubs, they may have open flames or cooking equipment. For our theater, they may have some stage with the specific effect and also the electrical equipment. Also, for a sport arenas, they have very large spans and the complex egress routes. And the passengers terminal may have some constantly changing occupant loads. Those kind of special amusement building may internationally disorient visitors. So each of these require the fire safety measures. In a nightclub, for example, some strict control on the seating arrangement and the exit visibility is very important for keep the fire safety. Also, some common hazards in the assembly occupancy include the cooking equipment, special stage with flammable material, and also the projection booth with the electrical gear. And also the storage area containing some combustible items. So for in a hotel ballroom, decorative stage can contribute to the fire spread. And also the proper storage practice, use of flame resistant material, and the regular inspection of electrical installation are some useful method for minimizing this risk. The prevention is always the first line for the defense. So the key life safety concept for the assembly occupancy includes several characteristics, as we can see in this slide. So the use of the fire resistance construction and the reliable alarm systems, some panic hardware on exit doors, and the appropriate interior finish. Those of these assembly occupancy key life safety concepts can work together to keep our peoples. For example, in a museum, the staff should be trained to assist visitors with some kind of disability during the evacuation. Also, some panic hardware ensure that the exits can be opened quickly, even under the crowded pressure. So these elements can work together to create a comprehensive safety net. Okay, so this is for our assembly occupancy. And let's take a break for 10 minutes. And after that, let's look at the karaoke establishment. Okay, so now let's start our class. And in this class, we will focus on the karaoke establishment. The karaoke establishments are particularly popular in Hong Kong, but also present some unique fire safety challenges. As we all know, in 1997, the top one karaoke fire tragedy results in 17 fatalities. This accident highlighted the need of the specific regulations. So in this section, we will explore how fire safety management is applied to these entertainment venues, from the hardware design to the software management. The safety in karaoke depends on a combination of hardware, such as the passive building design and the active fire service installation, as well as the software, including the fire safety management and also the staff training. So this integrated approach ensures that both physical system and the human factor are addressed and also combined together to consider our karaoke life safety. For example, even the best alarm system is ineffective if the staff cannot trained to respond appropriately. So a well-designed fire safety plan for karaoke includes two distinct modes. The first one is normal operation, and the second one is the emergency operation. So during the normal operation, the focus is on prevention through the maintenance, staff training, and the fire prevention plans. But for the emergency modes, the priority comes to the immediate action, such as the evacuation and the firefighting. So these two approaches ensure that the establishment is prepared for both routine safety management and the crisis response. Okay, now let's move from the general concept to a structured framework. So this slide introduces a powerful tool that is the fire safety management matrix. We can think of this as a central nervous system for organizing all safety activities within a special buildings, like the karaoke establishment we have been discussing. So the core idea here is the safety isn't a single mode operation. It has two distinct, and these two distinct are interconnected. That is the normal modes and the emergency modes. So for the normal modes, we have I equals to 1 for all the items. And for the emergency modes, we have I equals to 2 for all the items. And let's look at the items in the row of this matrix. So firstly, we have the passive building design. And also we have FSI. So what does it mean, FSI? That is the fire service installation, right? And also for the risk factors. So for all of these items, we have the normal element and also the emergency element. And also we have the suffix G, start from 1 to the total number of the management schedule, MKI. So that means the MKI, it is the maximum of the schedules for keeping the case group working in the ICE mode of the operation. So let's have an example. So if we have the, let's have an example. So for the, let's say the third pillow, for the third pillow, we have the risk factor that is Rij and R2J. And we have noticed that the J means the counter. And if we have the J to the maximum management schedule, MKI, we can get the maximum number of the schedule. So for example, we have R15. What does it mean? R15 would refer to the fifth specific management task for the risk factor. And if we have the B15, that is refer to the fifth specific management task for maintaining the passive building design during the normal operation. So this structure rate number allowed us to be incredibly precise in our planning and documenting. And we need to mention that the K, this MK, the K equals to B is for the passive building design. And the K equals to F, that means for the fire service installation design. So how about the K refers to R? That means for our risk factor design, right? So also for each MK, we can look at this matrix. Building on the matrix framework, we can move this into some management schedule the MKI actually contains. So we can break it down to the abstract concept into this actionable plan. So equation 1 tells us that we have 1, 2, 3, 4, 4 parts in our pillar. So that for any given pillar K in any model I, the total management effort is the summation of these 4 distinct types of activities. So let's look at the first one, the capital MKI. The capital MKI means the maintenance plan. So these are the routine check and the service. For instance, testing the pressure on the fire hydrant system or ensuring the emergency exit that are emulation for our MKI. And also the second one, the capital SKI. The capital SKI means the staff training plan. So this involves the education of the personnel of our staff. Sometimes means we can train them to conduct the fire drill or how to use a fire extinguishers to our personnel. And for the PKI, the second term in this equation, that is the fire prevention plan. So these are some proactive measures to reduce the hazard, such as enforcing a no smoking policy or controlling the storage of the combustible material. And the final one, the AKI. The AKI means the fire action plan. So we can know that is the set of some immediate action, immediate response for an emergency, like a specific protocols for the evacuating customer or for the meeting the fire department upon their arrival. So now here is where the logic of separating the normal and the emergency model become the crystal clear, as shown in this equation 2 and the equation 3. So let's explain those equations. Sorry, for the equation 2, we have the normal operation mode because we have this equation, we have this equation with I equals to 1. So that means there should be no element in the fire action plan. So we have letter AK1 equals to 0. That means we have no fire action plan. And similarly, for some emergency operation, that means I equals to 2. That there should not be any items related to the maintenance plan or staff training plan for the fire prevention. So in this case, we have such MK2 and the SK2 and the PK2 equals to 0. So that is the way we can separate the normal operation and the emergency operation for our total MKI. That is the total management schemes. Okay, so as we mentioned before, the tragic karaoke fire leads to calls for the regulatory oversight. So it is recommended that a single government department, such as the Fire Service Department, be responsible for licensing and enforcement. So this avoids the confusion and the gaps that can occur when the multiple agencies are involved. So clearly, the clear accountable improves the compliance and ensures the safety standards are consistently applied. So that means we can control the legislation by a single government department, that is our fire service department, to keep this kind of entertainment avenues to keep fire safety. So the karaoke establishment in Hong Kong are often located within the mixed-use building. They share the space with the restaurants, office, or some residential units. So this kind of complicated fire safety management as risk from one occupancy can affect another. So for example, a fire in a restaurant kitchen on a lower floor could threaten the karaoke on an upper floor, right? So therefore, some compartmentation and the coordinative emergency planning are very critical for our establishment. And also, the karaoke are characteristic by their popularity as the social venues, especially on the weekends or on the holidays. So they typically feature some small soundproof rooms connected by some long, narrow corridors. So the enclosed layout can hinder the detection and the evacuation. Additionally, some unique decoration and furnishing may increase the fire loads. So we need to understand what? We need to understand those characteristics in the first step of the karaoke establishment in developing our effective safety measures. So as we mentioned before, and here we repeat again, the 1994 fire at the Top One Karaoke was a critical moment for the fire safety in Hong Kong. So the fire, believed to be caused by some kind of cocktail, spread very rapidly through the soundproof rooms where the occupants could not hear the alarms. So we need to know that is the critical reason of this strategy. That is, the occupants could not hear the alarms. So 17 people lost their lives and many others were injured. And this tragedy exposed some critical weakness in the alarm audibility and also the exit design and the regulatory coordination. So it led to the public outcry and the demands for reform. So in the wake of the fire, legislators and the professionals called for the licensing system for the entertainment venues. At the time, karaoke could operate under various licensing, such as the restaurants or the club license, with some inconsident safety requirement. And the Decorative Party, among the others, argued for the unified standard and the better internal department coordinations. So this highlights the need for a dedicated karaoke establishment ordinance to ensure the consistent safety oversight. So here is our karaoke establishment bill. So the subsequent consultation paper for the karaoke establishment bill identify several key concerns. So let's take a look at of those main point of the concern. So firstly, they require to widen the corridor. They require to widen the corridor. The internal corridor width is required to change from 0.05 to zero point 0.2 meters. And also, they require that all dead ends corridor should be eliminated. And also, the walls separating the karaoke boxes and the corridors should have what? At least 1 hour fire resistant period. So these measures were aimed at improving the escape routes, safety, and preventing fire spread. However, they also raises questions about the feasibilities and the cost for some existing establishment. So as we know, complying with the new requirements poses significant financial challenges for some existing karaokes. So such as the modifying the corridor width and remove the dead ends and upgrading the partitions require substantial investments. Some operators feared that the cost would force them out of the business, leading to some job losses. So for new karaokes, however, those requirements could be incorporated from the outset. This highlights that the tension between improvement safety and also the economic viabilities. So the Karaoke Establishment Ordinance and its associated regulations come into effect in January 2003. So this legislation established a dedicated licensing system to ensuring fire safety and also the building safety and the public safety in the karaoke venues. So it marked a significant step forward in the regulatory control and provide clear standards for design, operation, and the maintenance. So to ease the burden on some existing operators, the ordinance include a 12 months transitional period. So during this transitional period, karaoke that were already operating could continue their work without a license and provided they applied for one license within this transitional period. So this allowed some operators time to understand the new requirements and make necessary upgrades without immediate closure. So when it comes to the locating karaoke, the establishment, the regulations are very specific and for some good reasons. So those laws clearly states that these venues cannot be situated on the basement level 4 or below. As we can see here in the first A, that is means if the karaoke venues, if they situated on the base level 4 or below in some industrial buildings, that is cannot get the permit from our ordinance or from our licensing parties. So why such strict rules? As we all know, the deep basement poses severe challenges for some evacuation and the firefighter access. So the industrial building often utilize the flammable materials and the process, increasing the overall fire risk. So this fire risk increased by the industrial building will affect our karaoke or some entertainment venues. Also, the requirement for a buffer zone acts as a crucial barrier to prevent fire spread from the industrial area to the public entertainment space. It is also another way to protect our lives in the karaoke venues. So now let's look at some general requirements. The materials used inside a karaoke establishment are a major focus of the fire safety regulations. So all combustible material used in false ceiling, partitions, or wall furnishing must conform to British standard. So now we have several British standards for our karaoke and entertainment. Firstly, we have the British Standard 476, especially achieving a Class 1 and the Class 2 rating for the rate of the surface flame spread. Alternatively, they can be treated with fire retardant paint. Similarly, any curtains must be made of the fire resistant material, meeting the British Standard 5867. So it is about the fundamentally reducing the speed at which a fire can grow and spread along the surface, buying the pressure time for the evacuation and the firefighting interventions. So even the carpets on the floor are subjected to the strict control, particularly within the protective means of the escape. That is your vital exit routes. So the regulations specify that the carpets must be made of the pure wool, which is naturally more fire resistant, or they should be conformed to BS 5287 when tested. So there is also an interesting provision. If the carpet does not exist 10 millimeter and it covers no more than 5% of the escape routes on the floor-by-floor basis, it might be acceptable. So this approach recognizes that the small, low-pile mats might not significantly contribute to a fire, but a large, thick carpeting could become a major fuel source and a tripping hazard in a smoke-filled corridors. Also, let's look at the furnitures. Moving to the furnitures, the regulations extend to what is inside the upholstery. So all the polyurethane foam-filled mattress and this kind of furnitures must conform to BS 7177 and also the BS 7176 for use in the medium hazard premises. So the karaoke boxes with their seats and sometimes the beds represents a significant hiding fire load. This foam can be highly flammable and produce some toxic smoke when burning. So by maintaining these British standards, the law ensures that the furniture has improved resistance to ignition from the smoldering or some small flame, so which are common causes of the fire in relaxed social settings like these karaokes. Okay, so this kind of exit sign, it is also very important. So this requirement addresses a critical life safety issues, visibility during an emergency. So we need to sound visible in our evacuations. So all exits must be clearly indicated by illuminated signs bearing the word exit. But the rules go further. Where an exit sign is not directly visible, adequate directional sign must be provided. So most importantly, low-level directional sign must be installed at around 200 millimeters above the floor level. So why so low? Because in a fire, smoke rises and the occupants may need to crawl to avoid the toxic gases. So these low-level signs become their only guide, shining a literal passage to the safety when standing is no longer possible. So these rules ensure the occupants are never left in the dark eternally. So for an exit plan drawn to a scale of at least 1 to the 200 must be displayed in every customer rooms. So this isn't a tiny schematic. It must be at least 250 plus by times by 250 millimeter, and affixed next to the exit at the height of what 1.5 meters. So this allowed our customers to quickly orient themselves and know the directions to the nearest staircases. And furthermore, those kind of emergency lighting is mandatory. So this isn't just about the convenience. It is about ensuring that if the main power fails, the escape routes remains illuminated. That can prevent the panic and the guiding people to safety. So this is a brilliant and very specific requirement. A short fire safety film must be shown to customers before they start their karaoke sessions. Think about this. This is a captive audience. So this film can briefly educate them on the location of the exits and where the alarm sounds like. What the alarm sounds like, and where is the location of the exits, and some basic evacuation procedures. So this kind of film can turn our audience from the passive attendants into some informed individuals. And also, in emergency alert system must be capable for some interrupting music and video to broadcast a warning. So in soundproof rooms, this override function is absolutely critical. It is the only way to ensure that everyone hears the alarm and receives the potential life-saving instructions. Okay, so now we move to the mandatory active fire safety system. First, as we have known before, is the fire hydrant and the hose reel system that must be provided for the initial firefighting attack. And secondly, a manual fire alarm system is required. And this ensures that no matter where a fire is discovered, a person can quickly raise the alarm. And crucially, the alarm bells must also sound with each individual karaoke room. And the requirement for the automatic sprinkler system is also carefully tiered based on the risk. So for the higher risk location, like the premises in some curtain walled buildings, on the basement floors, or those existing 230 square meters, a full automatic sprinkler system using fast response head is mandatory. And for some other fast response heads, activate more quickly in a fire, crucially for protecting lives. But for some medium-sized precise, that between the 126 and the 230 square meters, as we mentioned before, that is a chassis. Either we can use an automatic fire detection system, or we can use a sprinkler system. And additionally, in a large curtain wall or basement venue existing, that is 7,000 cubic meter. There is a mechanical smoke extraction system required to manage and remove the quantities of the smoke. So we come to the ventilation system. The ventilation system plays a critical role in our comfort and the safety. So this system must comply with either the ventilation of scheduled premises or the building regulations, ensuring the good air quality. But from a fire safety perspective, the most critical requirement is the installation of this automatic cutoff device. So in the event of the fire, this device must shut down the mechanical ventilation supply. It is very vital to prevent the ventilation system from actively pumping the fresh air to the fire, feeding its oxygen, and from spraying the smoke and the toxic gases throughout the building. So turning a localized fire into a building-wide catastrophic. Okay, now let's look at several previous government views. Both the building department and the fire service department have the specific responsibility for karaoke safety. The building department focuses on the means of escape, structural stabilities, and the fire resistance constructions. And the fire service department oversees some active systems like the alarms, sprinklers, and the emergency lightings. And the close collaboration between these departments is very important for the comprehensive safety. However, in 1997 tragedy, it revealed that the fragmented oversight can lead to these kind of gaps. So the new ordinance aimed to clarify the roles and improve the coordinations. So here, prior to the dedicated ordinance, the karaokes operated on the various silence. So each license type had the different safety requirement, leading to the inconsistency. Some karaokes even operated without any specific license, relying only on business registration certificates. So this patchwork system made some enforcement difficult and allowed the substandard condition to persist. So that is some kind of old license. And here is our code of practice. It is a kind of new regulatory framework. So for the new regulatory framework, it brought together the existing code of practice, such as the means of escape, means of access, and the fire service installation. And this provides a unified set of the standards for karaokes, regardless of their specific business model. So for example, all karaokes must now comply with the same requirement for the corridor width, and also the exit signage, and also the alarm systems to ensure a baseline level of the safety. These new codes introduce several good practices, such as the audio-visual advisory system that can interrupt the music during an emergency, and the low-level exit signs for the visibility in smoky conditions, and the alarm bells in every room. So that is why we need to get some good points of these new codes. And also, the manual alarm switch to required at the key location, and the ventilation system must have automatic cutoff devices to prevent the smoke spread. These kind of measures also address the specific challenge of the karaoke, such as the high ambient noise and some complex layout. So, which kind of good points of these new codes you think is the best important in our karaoke safety? You can think of these questions. What kind of good points of the new codes is the most important one for our karaoke safety? Alarm bells, or some manual alarm systems, and also some automatic cutoff device. So from my personal perspective, the most important might be the automatic cutoff device because it can interrupt our music or our videos during the karaoke establishment, and some also they can get our ventilations and the air conditioner systems activate. So that is might be the most important good points for this kind of new code. So to inform the new regulations, several surveys were conducted between 1998 and the 2000. So those studies collect data on hardware features like some passive design and the file systems, and also the software factors like the file load density and the occupant load density. So those findings highlighted the common deficiencies, such as the inadequate corridor width and the insufficient alarm audibilities. So this evidence-based approach ensures that the new requirements were targeted and practical. So that is why we sometimes need some surveys on our fire aspect, not only for karaokes, but also for some other places, such as we mentioned before, the historic buildings and the assembly occupancies. Now let's come to our special features of our karaoke. So karaokes are typically subdivided into several rooms, and these rooms are very small and soundproof. But this kind of small soundproof rooms are connected by a long and narrow corridors. So this layout can create such maze-like environment, this kind of maze-like environment that is difficult to navigate during an emergency. Additionally, an enclosed structure may limit the natural ventilations and the visibilities. So the fire-resistant construction is needed both within the karaoke and also at its surface with the rest of the building. Also, the compartmentation is the critical part to containing the fire and the smoke. So we can see that these maze-like entertainments and entertainment venues and also some furnitures inside the karaoke and also some outside such as the decorations of our karaoke buildings, we need to all keep their safety during our utilization. Okay, now let's move to the practical tools for assessing the fire safety in these existing buildings. As we mentioned before, we have several buildings. Some of the buildings are the new karaokes, and some of them are the existing buildings. And we have also mentioned that the existing buildings, they have been worked or have been utilized for the time before such as modern code has been established. So how can we deal with this kind of the existing buildings? Because we know that if we comply comply those existing buildings with these modern standards, it is not truly possible because it is such as the cost efficiency, and we also need to consider about our such as the business and also our cost. But if we use this kind of the ranking system, we can evaluate the fire safety by using the ranking system for this kind of existing karaokes. So that is a very important point for our modern codes that use the ranking system to evaluate the fire safety and to propose some new or some feasible method to keep our karaoke safe. So in our fire safety ranking systems, we have some codes that regard to our hardware, such as the passive building design and the active FSI, that is the fire service installation. The fire safety ranking system provides a point-based methodologies to answer these very questions, such as what about the thousands of buildings established before the rules come into effect? So its primary objective is to measure how far an existing karaoke established or any similar special buildings deviates from the expectation by the new updated codes. So the system evaluates three core areas. The first one is the passive building design, which is the built-in structure protection, and also the active fire service installation. That is the operational system like the sprinklers and alarms. And finally, the crucial element of the risk factor, which includes the variables like the occupant load. So the total score from this assessment doesn't just give a number. It will directly inform the required fire safety management and creating a direct link between the hardware deficiency and the software solution to achieve the total safety. So as we see here, it is crucial to understand the philosophy behind this 15-point FSRS. That is a 15-point FSRS. So it isn't a voluntary guidelines, but it is a rigorous scoring system grounded in a local building and the fire safety codes. So each of these attributes within the system corresponding to a specific mandated requirement. For any new karaokes, full compliance, a perfect score of 15 is not negotiable. However, for some existing venues that built in several years ago on the different standard impose the challenge for us. They cannot often practically or financially meet every new rules. So the fire safety ranking system acknowledges this reality. So it quantifies their shortcomings, and importantly, this is not a system where you can trade off a dangerous electric system for a wide corridor. So the safety parameters are independent. Each must be addressed. The final score then put requirement to a fire safety management program to systematically upgrade the premises to an acceptable fire level. So let's look at this 15-point karaoke ranking system. So firstly, we have the hardware. That is the passive building design. And we can starting with the hardware of the passive building design. So firstly, it's the location of the building. The location within the building is the first parameters. A level above the ground, that is the height, is less than 50 meters, we will get the 0.1. And otherwise, we will get the 0.00. And the next one is the evacuation routes. You can get a point for having at least the number of the exits required by the new building department code. But you will lose a point if you have fewer. So please notice for the location, if otherwise you will get a 0.00, but for the evacuation routes, if you get the fewer evacuation routes, you will lose your point. That means you will get -1. And also we have some corridor width. We have the requirement for the corridor width. The corridor width is very critical. A width of the 1.2 meters or more will score a point. Between 1.05 to the 1.2 meters, will score 0. But if your corridor width is less than 1.05, you will get -1. That means you will lose your point. It is very critical, right? And also, we get the presence of the dead end. The presence of dead end is severely penalized, as it having some internal partitions with the fire resistance period of less than 1 hour. So these parameters will collectively ensure the fundamentally physical structure supports rather than hinders and the safe egress. And we also get some other tables for our hardware, that is the file service installation. In here, we will evaluate the active system, the file service installation. So for the mandatory system like the fire hydrant and the manual fire alarm systems and the fire extinguishers, the scoring is strict. If they are provided and in good working condition, you will get score 0. But if they are missing or defective, you immediately lose a point. For other systems, which may not be mandatory in all cases, but greatly enhance the safety, the scoring rewards their presence. We can say such as the provided in some, let's say some other the exit system or some emergency lights. This is the kind of system that might not be mandatory, but it will greatly enhance our safety. And if we provide a well-maintained fire detection system and an automatic sprinkler system and also the smoke control system, each will earn a valuable point. Similarly, some functional emergency lights and the clear exit signs are worth a point, where their failure results in a deduction. So by using this table, we can know which one is more important and which one we can use it. It's not the mandatory. So we need to know the important, we need to know the mandatory, and we need to know which is the basic line for our the file service installation. So this is the last table of our fire rating systems. In here, we assess what? We will assess the risk factor, that is some software-driven. The software-driven risk factor, which can carry significant weight in a total score. So the first is the fire load density. The fire load density from movable items like the furnitures and the decorations. If the fire load density is kept at or below 1,135 megajoule per square meter, you will gain a substantial 3 points. That is a very good point you can get, right? So existing this threshold, however, you will get 3 points deduction. That reflect the dramatically increase the fire severity. And also the second factor is the occupant load factor. So we will get 2 points for meeting three key criteria. That is providing at least 1 square meter for customers and 0.75 square meter for customers in some specific area, and the 4.5 square meter for our staff. If you fail to meet this benchmark for the safe occupancy, will result to a 2-point losses. So this factor highlight that the management control over the combustible and the crowded density is as crucial as the physical hardware itself. So these three tables reflect our fire safety ranking system, and you can know, as we mentioned before, the mandatory, the important, and some baseline of our key factors. So you can take a picture for these tables, and it will be maybe accessed in our final examination. Okay, so let's take a break in this class. And for the next class, we will have some knowledge for the fire safety management scheme. Okay, so in our last class, we have a tool to evaluate the safety level through the FSRS, that is the fire safety ranking system. Then we need a treatment plan. So this is where our fire safety management scheme, or FSMS, comes into play. So the core insight here is that even if a building's hardware, such as its passive design and the active system, scores very poorly, we have some robust and intelligence management to create a safe environment. So, the FSMS is the proactive framework of the management protocols. So it is specifically designed to ensure a safe environment and a more reliable egress pattern during a crisis. Crucially, the scheme operates in two distinct models to reflect the realities. That is the first one, the normal modes, that is the normal modes on the ordinary usage, and also the emergency modes under an accident. So this two-mode approach ensures that every action from routine maintenance to the emergency duties is part of the cohesive safety strategy. So the bridge between our fire safety ranking system and the operational fire safety management scheme is the concept of action level. Once we conduct the risking assessment, we calculate a total score out of the possible 15 points, right? And the score is not just a rating. It is a direct indicator of the required managerial intensity. So this score tells us precisely how far the establishment provisions have deviated from the modern code standards. And based on these codes, we assign the building to a specific tier of the fire safety management requirement, with lower scores triggering more rigorous and frequent management actions. So this systematic approach ensures that the fire safety management program we develop is not a one-fits-all document, but it is a tailored response that is directly related to our building's specific risk profile and also the physical shortcomings. So for our action level, we have three of action level. So we defined these three action level clearly. The first one is the action level 1. That is our target. This is for those establishments that satisfy all or nearly all of the new requirements, achieving a full or near full score of the 15 points. So their management plan can focus on maintaining this high standard. But for the action level 2, it's for the majority of the existing building that fail some requirements, and it get the score between the 6 to the 14 points. So they have several safety features in the practice, but also have some identifiable gaps that must be managed. So we also have the action level 3. That is for those buildings. That is a very critical level for the establishment satisfying only a few requirements, scoring less than 5 points. So being in the action level 3 indicates a significant deviation from the safety standards, requiring what an immediate and intensive and highly structured management intervention to mitigate this risk and until those hardware has been improved. So this chart provides a visual representation of how karaoke establishment were distributed across this action level in a real-world service. So the horizontal axis shows the FSRS score from 0 to the 15. And the vertical axis shows this percentage of the establishment. So as we can see from this chart, you can see that a portion of the venues achieve our action level 1, that is from the score between the 14 and the 15. But a majority of the venues falls into this action level 2 from the score of the 8 to the 13th. And we can also see that a few of the venues, this karaoke establishment falls into the action level 3. So this graph quantitatively demonstrates the processing need for the FSMS for our management scheme, showing that a significant number of existing premises require some substantial managerial oversight to ensure our fire safety. So the aim of the FSMS, the Fire Safety Management Scheme, is the seamless integration of all safety components. This means that the management and the staff within a karaoke establishment must have a holistic understanding of how everything can work together. So they need to know not just their individual tasks, but they also know how the engineering service, like some smoke control systems, interact with the safe escape routes. So this is very important, and this integrated knowledge ensures that all fire safety features are not only available, but are in proper working order, and that no undue fire risk are present, like some blockade exits or some storage combustibles. So this holistic control is what allows the occupants who may easily panic and have limited time to react. It is difference between a collection of the safety parts and a fully functioning safety systems. So, what are the core components of this fire safety management scheme? It is formally listed in a fire safety plan which is comprised to 3 key documents. The first one is the maintenance plan, which details the schedules for inspection and servicing all fire safety equipment. And the others is the staff training plan. The staff training plan, which ensures all personnel are professional in their prevention and the response roles. And the second is the fire action plan. The fire action plan provides the step-by-step emergency procedures. So these are often compiled into a single, easy-to-use fire safety manual. As we have emphasized, the entire plan operates under 2 distinct modes. The NM, that is the normal modes, for daily prevention, and the EM, that is for the emergency modes, for the crisis response. So this slide detailed the specific management actions for the passive design, fire systems, and the risk factors. For example, during a normal operation, storage of the combustibles should be controlled, and the electrical appliance should be monitored. But during an emergency, smoking and the cooking must be prohibited, and the occupant's loss must be managed. These protocols ensure that the human behavior supports rather than undermines the physical safety measures. Okay, now let's examine the engineering evidence that inform the regulatory adjustment. So we can use, as we know before, the computational fire dynamics to model the fire environment, especially employing the two-layer zone model. So we can conduct this fire environment simulation by using CFAST, a software. So the key question was, what is the actual impact of widening the corridors from the 1.005 to 1.2 meters on our fire conditions? So the simulation setup involve a fire starting in a karaoke box, spreading to the corridor and an adjacent room. So the results was reviewing. As you can see from the data table, the critical parameters like the average smoke layer temperature in the corridor remains virtually identical at 104 degrees centigrade for both rates. And similarly, the average smoke layer interface height, which tells us how quickly the smoke will fill the space, was unchanged at 1.42 meters. So this indicates that from a pure fire physics perspective, the increase in width does not significantly improve the tenability condition within the corridor during a fire. So how about the evacuation design? We can also using our software to do the simulations. So complementing the fire environment in analysis, we can conduct some evacuation simulation using this kind of software. That is the building exodus. This model simulated the complex process of the occupants moving from the individual karaoke box and through the corridors and finally out of the building via the floor exits or staircases. So we can test it various corridor width. Even we can extending the analysis up to what? Up to 2.0 meters. The findings were consistent with the fire data. Under the normal occupancy loads, the reduction in total evacuation time was not statistically significant. And the bottleneck it appears is not necessarily the corridor width itself, but other factors, maybe like the flow capacity of the final axis and the stairwells, and also the decision-making times of the occupants. So this image of a long, narrow corridor underscore the environment, but the simulations tell us that simply making it wider does not guarantee a fast escape. So it is very interesting, right? So if we combine the findings from both the simulation modes, from our fire data and our evacuation data, we can draw an evidence-based conclusion on the issue of the corridor width. So our engineering analysis demonstrates that the fire environment in terms of the temperature and the smoke distance is not sensitive to the small increase from 1.005 to 1.2 meters. Simultaneously, the evacuation efficiency does not see a significant improvement on the normal conditions. Therefore, the assumption that increasing the corridor width in this specific karaoke is not necessarily true. So, this simulation provided the scientific justification for our building department to relax the strict requirement for the existing establishment, allowing a more practical and risk-based approach to our safety upgrades. And similarly, analysis indicates that providing 1 hour fire resistance to the internal corridor walls was less critical than, than what? Than controlling the surface flame spread. So that means if we can control the surface flame spread, such as we can use some fire resistant materials, we will have better performance than providing 1 hour fire resistance to the internal corridors. So the full-scale burning test also recommended for our karaoke box. It would provide more relevant data on the real fire behavior. So this kind of insights help to refine the regulatory focus from the prescriptive construction to our performance-based outcomes. Also, based on our research findings, the buildings department relaxed some requirements for the existing karaokes. The corridor widening was waived if the basic safety measures were in place, and the dead-end situation will also assessed case by case. So it will give some opportunities to the existing karaoke box to continue their work if they cannot remove this kind of dead-end situations. So this approach balances the safety with the feasibilities and allowing the existing venues to continue operating while still improving the overall safeties. So the karaoke case demonstrates that total safety depends on integrating hardware and the software. So a tailored fire safety management scheme supported by the proactive management and also the staff training can, compensate for the physical deficiencies. So this holistic approach ensures that all elements, like the design, the systems, and also our human factors, should work together to protect our life and the properties. Okay, so our discussion today focus on a range of the sources, including the NFPA standards, the local regulations, and also the research on karaoke fire safeties. That is the PhD thesis from our Dr. Gigi. So this reference provides our foundation for evidence-based practice in the fire safety managed. So I encourage you to explore them further as you can deepen your understanding of this field. Okay, so in this class, we have covered a wide range of the special buildings, from our historic treasures to the modern karaokes. And we also explore how fire safety management must be adapted to each context. So I hope you can think critically and stay cautious and always respect the safety of people and the heritage. So in the next class, we will have our seminar group project. And I believe you have prepared for some topics. Maybe you can also relate it to your topics for our lessons today. For example, for some historic building with some the specific design, or also you can focus on some high-rise buildings, maybe some ICC or BOC towers. So I hope you and I believe you have prepared for a well slides and also the presentation for our next class. So I'm looking forward to seeing you in our next sections. Okay, so any questions for today's lecture and for the next class presentation? And you can also communicate with me for our for any topics you need to or you want to choose for your seminar project. Any questions? Okay, so that's all for our today's lecture. And seeing you next week. Yes. You can upload your individual your reflection after your presentation. Yeah, after your present, as well as your maybe the presentation slide from your book.